Generative AI represents a significant leap forward in artificial intelligence, often abbreviated as GenAI. Unlike traditional AI that recognizes patterns or predicts from existing data, GenAI models can create entirely new content. This content can take many forms, including text, images, music, code. The underlying technology is large language models, or LLMs. These models are trained on vast data sets of text and code, enabling them to understand context and nuance, and the intricate relationships between words and concepts. Their ability to generate human-like responses makes them incredibly powerful. For example, creative writing and complex problem-solving. This raw power, however, needs a framework to be effectively harnessed and directed. This is precisely where LangChain enters the picture. LangChain is an open-source framework designed for building language model-powered applications. It provides a comprehensive set of tools, components, and interfaces that simplify building sophisticated AI apps. Instead of a simple, stateless request-response loop, LangChain allows developers to create dynamic, stateful applications. It acts as a bridge connecting the LLM to other systems, starting with data, computation, and services. LangChain makes it possible to build applications that can reason, act, remember. At the heart of LangChain's power is the concept of an agent. An agent is more than just a direct interface to a large language model. It is an autonomous entity that uses an LLM as its reasoning engine to determine a sequence of actions to take. The agent is given access to a suite of tools and is tasked with accomplishing a user-defined objective. Instead of just generating a final answer, the agent engages in a thought-action-observation loop. Think. It reasons about the user's input. Act. It selects and invokes a tool. Observe. It reviews the outcome and decides the next step. The technical workflow can be visualized as a continuous cycle. User provides an initial prompt or query. That input is fed to the agent's core, the LLM. The LLM, guided by a specialized prompt template, doesn't answer directly. It reasons about steps and outputs a specific action to take, which tool to use, what input to provide to that tool. LangChain parses this output. LangChain invokes the specified tool with the input. LangChain captures the result. That result, the observation, is fed back to the LLM, completing the loop. Iteration lets the agent break complex problems into smaller steps. Example: what was the weather like in Paris on the day the Eiffel Tower was completed? The agent wouldn't know that directly. First, use a search tool to find the Eiffel Tower's completion date. After observing the date, use a weather API tool with the date and location, Paris. The returned observation is historical weather data, used to craft the final answer. This architecture makes LangChain agents dynamic and powerful. To make the concepts of LangChain tangible, we will focus on a practical, widely applicable scenario, building a customer support chatbot for an e-commerce company. This chatbot will be designed to handle common customer inquiries, providing a more efficient and responsive support experience. The goal is to create an agent that can go beyond simple, pre-scripted answers. We want our chatbot to be able to access specific order information, check the status of a shipment, understand the company's return policy. This requires the agent to interact with different data sources and tools, making it a perfect use case for demonstrating the power and flexibility of a LangChain agent. The primary function of this agent will be to assist users with post-purchase questions. Imagine a customer, Jane, who recently bought a product and wants to know its delivery status. Instead of waiting for a human agent, she can interact with our chatbot. Jane might ask, "Where is my order number 12345?" A basic chatbot might only provide a generic link to a tracking page. Our LangChain agent will do much more. It will parse the order number from the query, use a tool to look up that specific order in the company's database, provide a precise, real-time update on its location, and estimated delivery date. Beyond order tracking, our agent will handle complex, multi-step queries. For instance, a customer might ask, "My order number 67890 arrived damaged. What is your return policy, and how do I start the process?" This requires two distinct tasks. First, access a document or knowledge base to retrieve the company's return policy. Second, understand the steps for initiating a return, which might include looking up the order to confirm eligibility. Before we begin writing any code, it is crucial to assemble all the necessary software, services, and credentials. A successful LangChain project needs the right environment and access keys prepared. This preparation prevents interruptions later. For our customer support chatbot, the requirements split into a few key categories: programming environment language model service, additional Python libraries. Proper setup is the foundation for the entire application. You will need a Python environment. LangChain is Python native, so Python is non-negotiable. Use Python 3.8 or newer for compatibility. Use a virtual environment to keep your project clean. Venv or Conda virtual environments prevent dependency conflicts and make replication easy. Next, access to a large language model via an API. The LLM is the agent's reasoning engine. We'll use OpenAI models, GPT-3.5 Turbo GPT-4. Create an OpenAI account and obtain an API key. The API key authenticates your application's requests. Keep it secret. Never expose it in client-side code or public repos. Store the key as an environment variable on your development machine. Finally, list the specific Python libraries to install. The core library is LangChain. We'll also need the OpenAI library. You may need additional libraries to build your agent's tools. Alright, so with our prerequisites identified, the next step is to set up the project directory and install the necessary Python packages. This foundational process involves creating a dedicated folder for our project, initializing a Python virtual environment within it, and then using pip to download and install LangChain and its dependencies. Following these steps carefully ensures a clean, isolated, and reproducible environment. It's a cornerstone of professional software development. This structured approach prevents dependency conflicts and makes collaboration with other developers much more straightforward. First, you'll want to navigate to your desired location in your terminal or command prompt and create a new directory for the project. You can name it something descriptive like LangChain_support_bot. Once the directory is created, change into it. This folder will house all of our Python scripts, configuration files, and the virtual environment itself. Keeping all project-related files in a single, well-named directory is a simple but super effective organizational practice. Inside the project directory, the next crucial step is to create a Python virtual environment. Using the venv module that comes standard with Python 3, you can create one by running python mvenv. This command creates a new subdirectory named venv, a common convention, that contains a fresh copy of the Python interpreter and its standard libraries. To start using this isolated environment, you must activate it. On macOS or Linux, the command is source venv/bin/activate. On Windows, it is venv scripts activate. Once activated, your terminal prompt will typically change to indicate that you are now working inside the virtual environment. Now that the virtual environment is active, we can install the required packages using pip. After setting up our environment, the next logical step is to connect our application to the large language model that will serve as the agent's brain. This integration is a fundamental part of any LangChain application. The LLM is responsible for reasoning, planning, and language generation. For our customer support chatbot, we will use a model from OpenAI. The process involves securely loading our OpenAI API key and then instantiating a LangChain object that represents the connection to the model. This object will be used by the agent to process inputs and decide on actions. The first and most important part is handling the API key securely. Hard-coding your API key directly into your script is a significant security risk. If the code is ever shared or committed to a public repository, your key will be exposed, potentially leading to misuse and unexpected charges. The best practice is to store the key as an environment variable. To do this, create a new file in your project directory named NV. Inside this file, add a single line, OpenAI_API_key =, your _API_key_ here, replace your _API_key_ here. With the actual key you obtained from OpenAI, add the .nv file to your Gitignore so it is never committed. With the API key stored in .nv, we can now write the Python code to load it into our application. We will use the python.env library we installed earlier. At the very beginning of our Python script, import load_.env and call it. Load_.env automatically finds the .nv file in the project directory and loads the variables defined within it into the environment. An agent's true power comes not just from the LLM's reasoning, but from its ability to perform actions and remember past interactions. This is achieved by equipping the agent with tools and memory. Tools are functions the agent can call to interact with the outside world, searching a database, calling an API, retrieving a document. Memory lets the agent retain context for more coherent, stateful dialogues. For our customer support chatbot, we'll create a tool to look up order information and another to search the return policy. We'll also add a simple memory buffer. First, let's define the tools. In LangChain, a tool can be any Python function. To expose a function to the agent, use the @tool decorator from langchain.tools. Create a mock function to simulate looking up an order status. The function will take an order_ID and return a status string. In production, you'd query a database, but here a dictionary lookup suffices. Create a similar function to return the predefined return policy text. These decorated functions are now discoverable by the LangChain agent. Next, we need to implement memory. Memory components store and retrieve messages from a conversation. Simple buffers keep the last few messages while more complex systems can summarize the conversation. For our chatbot, conversation buffer memory is an excellent starting point. It keeps a buffer of past messages and passes them as context to the LLM. This is crucial for follow-up questions. Now that we have all the individual components, the LLM connection, the tools, and the memory, we can assemble them into a working agent. This involves bringing everything together in a single Python script. Define the tools, initialize the LLM and memory, create a specialized prompt template, and then use a LangChain constructor to build and run the agent. This script serves as the complete blueprint for our customer support chatbot, demonstrating how the different parts of LangChain interoperate. The script begins with the necessary imports and the secure loading of our OpenAI API key using dotenv, show full Python code sample. We then define our tools using the @tool decorator as previously discussed. One function, get_order_status, will take an order_ID and return a mock status. Another, get_return_policy, will take no arguments and return a string containing the company's policy. We then gather these functions into a list, tools =, get_order_status, get_return_policy, which we will pass to the agent constructor later on. Next, we create the prompt template. This is one of the most critical parts of building an effective agent. The prompt is what guides the LLM's reasoning process. We will use a template that instructs the LLM to act as a customer support assistant, explains the tools it has available, and provides placeholders for the chat_history from memory, the input, which is the user's query, and the agent_scratchpad, where the agent records its thought-action observation loop. Finally, we use the create_OpenAI_tools_agent function to construct the agent, passing in our LLM, the tools list, and the prompt. We configure the agent executor with our agent and tools, and importantly, we also pass in our conversation buffer memory instance to give it a conversational memory. Once the agent script is written, the development lifecycle is not over. The crucial final stages involve rigorous testing to make sure the agent behaves as expected. Then comes deployment so end users can access it. Testing is more than checking for errors. Evaluate performance, accuracy, reliability across many inputs. Deployment means moving the agent from local to a cloud server, a serverless platform, and exposing it via an API, a user interface. Testing a LangChain agent should be multifaceted. Start with unit testing individual components like tools. Test with valid order IDs and with invalid order IDs. Next, integration testing. Test the agent's reasoning. Use verbose =true in agent executor. It prints the agent's thought process. It's reasoning the tool selected the input to that tool, the observation returned. Review these logs to debug and refine behavior and prompts. Create a test suite of common queries and edge cases. Simple question, where is my order? Complex multi-step, my order was damaged. What's the policy? Conversational follow-up, what was that order number again? Automate these tests and compare outputs to expected results to catch regressions. This builds a trustworthy, reliable assistant. When ready, deploy. Wrap agent logic in Flask or FastAPI, expose as an API endpoint. Front-end chat widget sends messages to the endpoint and shows responses. Host the API on a traditional virtual private server. AWS Lambda Google Cloud Functions. Docker Kubernetes. Choose based on traffic, scalability, and team expertise. This turns your local script into a real application.